Welcome to Tech Explained. Every single time you type a web address into your browser, you're tapping into a 40-year-old system that acts as the internet's invisible map. It's called the Domain Name System, or DNS, and it's one of the most critical and, honestly, overlooked pieces of technology that makes the modern internet even possible.
So in this explainer, we're going to pull back the curtain on how this whole thing works. We'll start with the basics, then we'll look at its surprisingly old-school origins and walk through the step-by-step journey of a single request. We're also going to expose its hidden weaknesses and, most importantly, show you the modern solutions that can make your online life a whole lot more secure and private. So let's start with the core problem DNS was built to solve.
You see, at its heart, DNS solves one fundamental problem. Computers and humans just don't speak the same language. We remember names. Computers, well, they operate on numbers. DNS is the universal translator that bridges that exact gap. And here it is, right here, the translation in action. We remember something easy, like www.ecii.edu, but a computer needs a very specific numerical address to connect to, an IP address. Without a system to automatically connect that name to that number, the web as we know it would be impossible. Imagine having to carry around a notebook filled with long strings of digits for every site you wanted to visit. Yeah, no thanks.
So you can think of DNS as the internet's phone book, right? You don't memorize your friends' phone numbers anymore. You just look up their name in your contacts. It's the same idea. Your browser doesn't know the IP address for a website. It uses DNS to look it up by its domain name. This creates this massive, globally distributed directory that pretty much everything online relies on.
But this smooth, automatic system didn't just appear out of nowhere. To really get what DNS is all about, we have to rewind the clock to a time when the internet was a much smaller and, frankly, a surprisingly manual place.
In the early days of the ARPANET, the precursor to our modern internet, there was no automated system. There was just one single text file. It was called hosts.txt, and it was managed by the Stanford Research Institute, or SRI. Now get this, if you wanted to add a new computer to the network, you literally had to pick up the phone, call SRI, during their business hours, by the way, and have them manually add it. As you can imagine, as the network grew, this became completely unsustainable.
And this is where a researcher named Paul Maka-Patras enters the story. He saw that the old system just couldn't scale. It was a problem he set out to solve. So, in 1983, he designed the Domain Name System, creating the decentralized automated model we still use today. By 1986, it was the official standard, replacing those old manual phone calls for good.
Okay, so how does this system actually find the right number for a name you type into your browser? It's a pretty fascinating lightning-fast journey that involves 4 key players. Let's break down the anatomy of a DNS query. So it all starts when your computer sends a query to what's called a recursive resolver. This is usually run by your internet service provider. Think of it as a helpful local librarian. If that librarian doesn't have the answer, it first goes to a root server, which is kind of like the library's master index. It just points the way. The root server directs the query to the correct TLD server, which manages all the domains for something like .com or .org. And finally, that TLD server points to the authoritative name server. This is it. This is the one server that holds the official record, the book, with the correct IP address, which it then sends all the way back down the chain to your computer. And all of this happens in milliseconds.
Of course, doing that entire 4-step dance for every single click would be incredibly inefficient. And that's where caching comes in. To speed things up, both your computer and that recursive resolver save a temporary copy of recent lookups. It's like photocopying a document instead of driving down to the records office every single time you need it. This simple trick is what makes the web feel so incredibly fast.
But here's the problem. When DNS was created back in the 1980s, the internet was a small, trusted community of researchers. Security and privacy, well, they just weren't the top priorities. And that has left some pretty big cracks in the very foundation of how we navigate online today. And here's the fundamental issue. Traditional DNS queries are sent in plain text. They are completely unencrypted. What that means is that anyone positioned between your computer and the resolver, say someone on the same public Wi-Fi network as you, can read your queries. They can see a list of every single website you're about to visit. This lack of encryption opens the door to something called a man-in-the-middle attack. An attacker can intercept your unencrypted request and do more than just read it. They can actually change the response, redirecting you to a malicious website without you ever even knowing.
And this leads to an even more dangerous attack called DNS cache poisoning. This is where an attacker feeds a fake answer to a recursive resolver. The resolver, not knowing any better, saves this malicious IP address in its cache. Now, anyone who uses that resolver to visit their banking website, for example, could be unknowingly sent to a fraudulent copy that's designed to steal their login information.
Okay, so that all sounds pretty bad, right? Well, thankfully, the story doesn't end there. In recent years, there's been a massive effort to patch these foundational cracks. So let's look at how we can build a more secure and private DNS.
It really boils down to two distinct problems. First, there's authenticity. How can we be sure the DNS answer we get back is the real deal and hasn't been messed with? The solution for that is DNSSEC. Then there's privacy. How do we stop people from snooping on our queries in the first place? And for that, we have protocols like DO and DOT.
So DNSSEC, or DNS Security Extensions, tackles that authenticity problem. It works by adding a digital signature to DNS records. This lets your resolver verify that the answer is legit and hasn't been changed. It's a critical tool for data integrity. But, and this is a really important but, DNSSEC validates the answer. It does not encrypt the question. Your query is still sent out in the open for anyone to see.
Now, to solve the privacy problem, we've got two main ways to encrypt things. Think of it like sending a package. DNS over TLS, or DOT, is like putting your query in a secure, armored truck. It's very safe, but everyone on the highway can see that it's an armored truck. DNS over HTTPS, or DO, is a bit more clever. It puts your query in a plain, unmarked delivery van that looks exactly like all the other web traffic. And because it just blends in, it's much harder for anyone to spot and block.
So what does all this technology mean for you? Well, it leads to a really powerful conclusion. You don't have to just stick with the default DNS resolver your ISP gives you. You have choices that can seriously improve your privacy and security.
One of the most well-known alternatives is Cloudflare's 1.1.1.1. It's a free, public resolver that was built with a big focus on speed and a strong commitment to privacy, and it fully supports modern encryption like DOH and DOT.
Another major player is Google's public DNS, which you can find at 8.8.8.8. It's been around for a long time and is another really reliable option for anyone looking to switch away from their ISP's default. It also takes full advantage of encrypted DNS.
And for those of you who put security above all else, there's Quad 9. Its mission is a bit different. As a nonprofit, its focus is purely on protecting users. It not only encrypts your queries, but also actively blocks you from accessing known malicious websites, giving you an extra layer of defense against things like malware and phishing.
And the evolution here doesn't stop. An emerging technology called Oblivious DNS, or ODO, is pushing privacy even further. It uses a proxy to separate your query from your identity. So the proxy knows who you are, but can't read your encrypted query. The DNS resolver sees your query, but only sees the proxy's address, not yours. As long as those two don't conspire, your browsing history is kept private from both.
From a simple text file managed by phone calls to an encrypted, privacy-focused global system, DNS has come a very long way. The choices we make about this invisible map have a real impact on our security and privacy online. If this breakdown was helpful, let us know by liking this explainer and subscribe for more deep dives into the tech that shapes our world. Now, we'll leave you with this final thought. If your DNS queries create a map of your digital life, who do you trust to hold it?